Hello everyone, welcome back to another video. Today we'll be seeing some questions from the chapter of sequence series. Yeah, we are finally starting the chapter now. And I'll also be giving some more questions at the end of the video. So please try to answer them because if you do not answer the homework questions, what will be the point of watching the video? And I'll also name some people whom I expect to answer the questions in the comment section. Okay, so let us see the first problem. So in the first problem, we have been given that the pth, qth, and rth terms of an HP are x, y, and z respectively. Okay, and we need to find the value of this expression over here. First of all, the first thought that comes to my mind when I see an HP is that the reciprocal of its terms are in AP, because I don't know much about HP, but I know a lot about AP, right? So I'll be writing like the analogy which I came up with is that pth, qth, and rth terms of an AP are 1 by x, 1 by y, and 1 by z. This is what I'll be using. Okay. So can I write 1 by x as a sum a, which is the first term, plus p minus 1 into d. 1 by y as a plus q minus 1 into d, and 1 by z as a plus r minus 1 into d. Okay. So now we need to find the value of this expression. So in the expression, can you see that we need terms with p minus q, q minus r, and r minus p. So taking that as my reference, what I'm going to do is I'm going to subtract these two. And similarly, I'm going to find the respective terms for all the three terms given in the expression. Okay. So when I subtract these two, I get something like y minus x by xy is equal to p minus q into d. So we have created p minus q, right? So, but the expression asks the value of p minus q times xy, q minus r times yz plus r minus p times xz. So I'll be creating p minus q times xy now. So what I'll be doing is I'll be cross multiplying xy over here and bringing d over here. So what we get is y minus x by d is equal to p minus q times xy. Okay. Similarly, we'll get the other terms, the other two terms as x minus z by d, and the third term as z minus y by d. Okay. And when we add these three terms, we'll be getting the answer as 0. Okay. So my final answer would be 0. Okay, so let us move on to the next question. So here we have our next question. So first of all, let us read the problem, then we'll proceed on to the solution. So we have been given that A1, A2 are the AMs, G1, G2 are the GMs, and H1, H2 are the HMs between two numbers. And we need to find the relation between A1, A2, B1, A1, A2, G1, G2, and H1, H2. Okay. So what we're going to do here is, first of all, let us consider those two terms to be A and B. Okay. And A1, A2 are the AMs between them. G1, G2 are the GMs between them, and H1, H2 are the HMs between them. Okay. You would have studied that the sum of these two, a and b, is equal to the sum of these two terms. So first of all, we'll be deriving relations in a and b, like with a1, a2, g1, g2, and h1, h2, and then we'll be eliminating a and b. Okay, that is what we'll be doing. Okay, fine. So first of all, you would have seen that a and b, the sum of a and b is equal to the sum of these two, a1 and a2. Let me explain in a better way if you don't know the concept. So if we have two terms over here and these three are the AMs between them, then the sum of these two extreme terms is equal to sum of these two terms, which is equal to 2 times this odd term. Okay, and this goes on and on with any number of terms. So from here I can say that a plus b is equal to a1 plus a2. I got my first relation. Okay, and from here the same thing happens but with product. The product of these two is equal to the product of these two. So from here I can say that AB is equal to G1 G2. Okay, because I needed like the G1 G2 term from seeing the options, I knew that I needed the G1 G2 term. And from the same idea, I'll be doing a similar thing with these two. So here I don't know much about HP, but I know a lot about AP. So I can say that these four terms are in AP. So the sum of these two is equal to the sum of these two. So from here I can say that A plus B by AB is equal to H1 plus H2 by H1 H2, right? So can you see the obvious elimination we are getting over here? Let me show you. If I divide these two expressions, let me name it 1, let me name it 2. If we divide these two expressions, we get something like A plus B by AB. Okay, so A plus B by AB is equal to H1 is equal to nothing but H1 plus H2 by H1 H2, right? And this thing is equal to A1 plus A2 by G1 G2. Okay, So from here we got our we'll get our desired expression by rearranging the terms. So that is what we'll be doing. So can I say that G1 G2 G1 G2 by H1 H2 is equal to A1 plus A2 by H1 plus H2. Okay. I just rearrange the terms in order to get the desired option. So from here what we'll be getting is the A option, right? So here we have our next question. It is based on the concept of making telescopic series. I hope this would be like most of yours favorite concept. So let us see the question and see what we can do over here. First of all, let us write the summation over here. So we have r factorial times summation of r is equal to 1 to 99, r factorial times r square plus r plus 1. So I am thinking of, since there is r factorial over here, I am thinking of creating r plus 1 factorial. And from seeing this quadratic, I am getting the idea of making a perfect square. So that is what I'll be doing. I'll be having something like summation r is equal to 1 to 99. I'll be adding subtracting r in this expression. So from here I get, like by adding and subtracting r in this expression, I get something like r plus 1 whole square minus r, right? So let us open the bracket and separate the terms. We'll be having something like r plus 1 into r plus 1 factorial minus r into r factorial. Okay. So from here, I need to cancel out terms. So in order to cancel out terms, listen to this habit of mine. It is very useful. I do not write down all the terms and then cancel and show the cancellations. I can do the cancellations mentally. So what I did was I imagined the very next term to this term over here. The very next term to this term over here would be r plus 2 factorial times r plus 2 minus r plus 1 factorial times r plus 1. So I can see that this term over here gets cancelled by the very next term. And similarly, I can see that this term over here gets cancelled by the very previous term. So which term won't be cancelled in this expression if I write it? This term gets cancelled by the very next term. So the term which is not having the very next term will not get cancelled. That is, at r is equal to 99. This term doesn't have the very next term. So this won't get cancelled. All others will get cancelled because they have their very next term. So I'll be having something like 100 factorial times 100 minus this term, which term won't be having its very previous term. The very first term won't be having its very previous term, that is r is equal to 1. So I get something like this. This is my final answer. So option B would be correct. Okay, option B would be correct.